Welcome to the presentation on Basic Fundamentals of Electricity. In this presentation, we will learn the basic terms and concepts related to electricity. Let us first know about current. It is one of the fundamental terms when it comes to electricity. To understand it better, let us understand certain aspects like how does a bulb work? And how does your mobile phone get charged? The answer is electricity. Let us now learn what electricity is by knowing the working of a battery. A conductor is usually made of conducting metals like copper, which pave the path for the flow of current. Electrons carrying a negative charge use the conductor for traveling to the positive end of the battery. In other words, electrons begin their flow from minus to plus. The flow of electrons in the conductor is called current. Current is measured in amperes. Electric current is measured using a device called an ammeter. An ammeter is connected in series with the circuit. Let us next know about voltage. It is another concept of electricity. Let us first know what a particle is. Consider two water tanks, one above the other, with a water wheel between them. These tanks are placed in such a way that the water falling from the upper tank through a water tap will turn the wheel before splashing down into the lower water tank. The wheel will keep rotating as long as there is water in the upper tank. Now, if a person draws water from the lower tank and keeps pouring it back into the upper tank, the wheel will turn continuously. If the person stops working, the tank will become empty after some time and the wheel will stop turning. Water falling on the wheel makes the wheel turn because there is energy in the water stored in the upper tank. The energy associated with water in the upper tank is called potential energy. It depends on the difference in the height of the upper tank from the lower tank. The height of the upper tank from the lower tank is the measure of the potential energy and therefore there is pressure. The equivalent of water pressure in electric circuits is called voltage. Voltage may also be defined as the energy difference between the positive and negative terminals of a battery. Voltage is measured in volts. It is measured using a device called a voltmeter. A voltmeter is connected in parallel with the circuit. Let us now understand resistance, another component of electricity, by knowing what a resistor is. Let us consider an example. Suppose water is flowing easily through a pipe. What will happen if a stone gets lodged inside the pipe? The stone will resist and restrict the flow of water. Similarly, a resistor restricts the flow of electricity. What can happen if there is no resistor? There could be high voltage passing through the circuit and short circuits might occur. A resistor is a component which limits the flow of electric current. The symbol of resistance is R. Resistance is measured in ohms by a measuring instrument called ohm meter. Let us next learn about Ohm's law. According to Ohm's law, the current passing through a resistor between 2 points in an electric circuit is directly related to the voltage difference between the 2 points and inversely related to the electrical resistance between the 2 points. This law was formulated by Georg Simon Ohm, a German physicist. Ohm's law shows that Current varies directly with voltage and inversely with resistance. There are three ways to express Ohm's law. Given here is the formula. Let us now understand power, another concept of electricity. Power is related to voltage and current as given in the formula. Power is measured in watts and denoted by W. It is measured by a measuring instrument called wattmeter. 1000 watts is equal to 1 kilowatt. 1000 kilowatts is equal to 1 megawatt. Let us next know about energy, yet another concept of electricity. Energy in the electric form is used for moving charged particles through a wire from a power plant to our homes and businesses to lighten our houses or run our appliances. Energy is the product of power and time. A kilowatt hour is a unit of energy equivalent to 1 kilowatt of power expended for 1 hour. 1 kilowatt hour is equal to 1000 watt hours. Electricity consumption of any light or appliance is measured in terms of a unit. It is calculated as the product of number of hours of operation and power in kilowatts. With this, you have now learnt a few of the basic concepts of electricity.